Alright, in this video I'm going to walk you through the process of building your own platformer using Pygame Zero. So we're going to start off here with just an empty folder and get all the assets in this folder and get it set up before we actually start to do the code. So the first thing I'm going to do is I'm going to go to the Kenny website and download a tile set for a 2D platformer. So you can go to kenny.nl/assets and search 2D. And then there's going to be all these different options for different 2D platformers that you can use. So I'm just going to start with this one right here, the Pixel Platformer. And I'm going to hit download and download this right here. And then what I'm going to do is I'm going to open it up, and it's going to be in my downloads folder. So the first thing I'm going to need to do is extract this. And so I'm going to right click and hit extract all. And it's going to take it from this zip file to a folder with all the different pieces of information inside of it. And so inside of here, there's a whole lot of stuff. But the important thing is these tile maps here, which has all of the different assets loaded into one image. And this is going to help us lay it out here. And then if we go into the various like tiles folders, it has each one of those different images being shown. And these numbers here kind of correspond to the coordinate location within that big tile map. And we're going to use this later on. But for right now, what I'm going to do is I'm going to take this folder here and I'm going to move it into where we're going to be working. So I have this platformer demo folder right here. So I'm just going to move this right inside of here, just like this. And we'll be able to kind of refer to this later on. But this is where we're going to add all of our code. And so I'm also going to add a new folder here for images. And this is just kind of like the same images folder that we've had alongside all of our other projects here, so that Pygame Zero can find each of those images and show it. If you were also going to add music and stuff like that, you can add that here. So you would have one for music and then one also for sounds, just like that. And so in order to be able to show the images from the platformer, we'll lay out the level here in a second, but in order to show that, what I need to do is I need to copy everything inside of tiles here. And so I could actually just copy tiles like this. I'm going to copy it, or right click and hit copy. And then I'm going to go back up to my platformer demo, go inside of images, and paste this right here. And now our Pygame Zero will be able to see this, but one important step that we have to do first is we need to make it all lowercase so that it follows the correct syntax here that Pygame expects, where all the files have to be lowercase and there can't be any spaces. There just needs to be underscores between everything here. So that's one important step to not forget. But right now, this is what we've got here. So I'm going to open this up now inside of VS Code. So I'm going to go to New Window and drag it over here so that we can see it. And if I open this little Files tab here, I can hit Open Folder, and I'm going to navigate to where that platformer demo thing is on my computer. So it's right here, and I'll just hit Select Folder. And now we see that all of that same information is right over here. So there's the images, all the stuff that I downloaded from Kenny's website, and the music and sounds and all of that, even though it's empty. So what I'm going to do is I'm going to add just this right here. I'll say game.py, just to be our Python script that we're going to use to develop our game here. So we'll add code into this later, but for right now, this is kind of most of the setup that we will need to do. The very last piece here is you're going to need to go to my GitHub repository for this class. It's linked on Canvas, and this has all the different examples in it, as well as this platformer.py that has a lot of extra code behind it to handle sprites and level building that you will need for your game. So you can either download all of this and just bring in the stuff that you need, or you can just click here and hit copy, and it's going to copy everything that's inside of here. And so what I'm going to do is I'm just going to now go inside of here and create a new file, it has to be called platformer.py. And again, if you just downloaded it and dragged it into this folder, it would do the same thing. But now what I'm going to do is I'm going to paste this. This is all the code that I wrote for you to kind of help handle some of the weirdness behind creating a platformer. But you shouldn't have to touch anything. You just need to make sure that this code is here right alongside of wherever you're going to build your game. And then you're in good shape. So we're going to come back here to the code in a second. But now what we're going to do is we're actually going to build the level using a program called Tiled. And so I have Tiled downloaded right here. There's some information on Canvas about how to get in and download that and get it all set up. But this is what it looks like when you launch it for the first time. So what I'm going to do is I'm going to create I'm going to load in a new tile set. And so I'm going to hit new tile set, go to browse, and now I'm going to find that stuff that I downloaded here from Kenny. So if I go to documents, if I go to my platformer demo, and then go inside of the Kenny Pixel platformer, if I go here inside a tile map, this is what we are going to download. So there's a couple different versions of it. There's tile map and there's tile map _ packed. We're going to use this one because it's easier. And what it means by packed is just that all of the different tiles are laid right alongside of each other with no little gap or offset between them. So I'm going to hit open. And then what I needed to do is tell it the dimensions of each of the different tiles here. And so if you went back to the Kenny website here, it tells you that it is 18 by 18. So if you're using another resource, just make sure that you look at what the size of the tile is. And then you go back here and you say, okay, it's 18 by 18. There's no spacing or margin between it. It's packed in there. And then I'm going to hit save as. And I will go back to my same folder. So it's documents, platformer demo. And then I'm just going to save this right here. This is a tile set file that's just saving all this so that it's nice and laid out. And now what I need to do is I need to do new map. And I'm going to set up a map where I can lay out all these different things. And a map just means basically a level that we are going to lay out here. And so I want to make sure it's orthogonal, that the tile layer format is CSV, it's right down, and then the tile size is 18 by 18. Now this is the part that you can change right here. You can adjust the width and height of your map to be whatever you want it to be. I'm just going to do 30 by 20. That's fine for me. And then I'll hit OK. And so now you see I have this big thing right here, which is my level, and I can start laying out all of these different pieces here. So I'm going to start out just by kind of laying out the ground. And so you can select a bunch of things and then lay it all out at once, or you can select one square and then just click to add it. So I'm going to lay out this one here, which is the left corner one, this one here, which is the right corner one, and then this is the middle connecting piece that will go between all of those. And I can just click and drag that all the way across the bottom here. And then now we can add some little platforms for jumping here. So what I'm going to do is I'm going to put this, let's do that right there. And then I'll go over 2 and up 1, over 2 and up 1, over 2 and up 1. And I'm just going to keep kind of laying it out in this fashion here. And then once we get there, we'll maybe go up 2 so there's enough clearance to get there. And then we'll kind of go back to that same pattern. And just make sure that everything is laid out with enough space that the player can get between the spaces without getting stuck. But not so much space that they can't jump between it. So I think this looks good. All right, so I've kind of laid out this. We'll have the player kind of jump up all the way up to here and then be in good shape. So this is just our platforms. So I'm going to save this here. And this is actually saving the map itself or the level. So I'm going to go, where is it? Back to documents and platformer demo, and then just save this as platformer. Okay. So what we're going to need to do is treat each one of the different types of things in our map or our level as different layers. And that's going to help us bring them in separately in the game and the code itself so we can treat them differently. And so what I mean by different types of objects is like these are all platforms here. But say I might also want to have like different obstacles, like things that if the player lands on it, it would hurt them, or things that they would collect. I would put those on different layers so that we can have different things happen. So if the player lands on a platform, they shouldn't go through it. They should just sit there, but no damage is going to happen. But if they land on spikes, maybe they get game over, or if they land on a coin, they would collect it. So what I'm going to do is I'm going to right click over here where it says tile layer, and I'm going to rename it. Or actually, if you just double click it, you can rename it. So I'm going to call this platforms. All right. And then what I'm going to do is I'm going to create a new layer here, and I'm going to call it obstacles. And so when I have obstacles selected, I am now adding things in where they're into that layer. But if I have platform selected, I'm adding things to that layer. So what I'm going to do is I'm going to actually delete some of these things here so that we can remove certain parts of this and add in like spikes. So I'm going to go to the erase tool here, and let's see, I'll just kind of add it, I don't know, periodically throughout the bottom here. So I'm just going to erase certain parts here, just like this, and like this, and like that, maybe. Okay. And then what I can do is I can come here and I'm going to add spikes. But what I want to do is I want to add it in the obstacles layer. So I'm going to select obstacles, and then I can add spikes just kind of like this here. There we go. So we have some spikes in there. And these are in the obstacles layer, and we can kind of test this out by clicking on the eyeball, which will hide that entire layer. So when I hide it, we can see there's no spikes, and when I hide platforms, you can see there's no platforms. So that kind of indicates to us that we put them on the correct layer. And so we have our platforms that we want the player to land on. We have the obstacles that we don't want them to land on or the game will end. And let's add something for them to collect. So in this case, let's have them collect like little mushrooms. And we'll just put one kind of on each of these different things. But what I need to do is we're going to treat these differently in the game. So I actually want to undo what I just did. So I'm going to hit Control Z and add these onto a different layer here. So I'm going to hit New Tile Layer, and I'll just call this one Mushrooms. And then I can add them here. And now they will be on the mushrooms layer where we can treat them kind of differently in the code. So we're just going to keep going like this. Cool. And hopefully did the spacing all right so the player can jump between there without a problem. And so now I can hit Control S to save it, and this little asterisk will go away, indicating that we've saved the level. But in order to be able to bring this into our program, we're going to need to go to File, and then go to Export As, and then we're going to export it as a CSV. And then again, we're going to need to make sure that we go to our platformer demo, or wherever you're saving everything, just make sure it's all in the same place. And I'm going to hit Save. And it's going to create several different CSV files, which stands for comma separated value files, for each of these different layers. So if I go now here, where is it? Platformer demo, we can see I have mushrooms, obstacles, and platforms.csv, which is a table type file. Like I can open it here in Excel, and it will show you where all these different pieces are going to be. So -1 represents that there's nothing there in the tile map. And then 128 is the specific coordinate within the tile map of the mushroom. So it's indicating, hey, put a mushroom here, 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 and so on. And so it shows on this layer, this is the location of all the mushrooms. If I open up the obstacles one, it shows me basically where all the different obstacles are. So here's all of my spikes. And then if I open up the platforms one, it shows me where all the different platforms are. So that first one's tile 1, this is tile 2, and then this is 77, 78, 79 for that little trio platform that I added throughout. And you can kind of see how this looks like the map. So what we're going to do is bring this into our program so that we can actually display this in Pygame Zero. We're going to interpret this information and use these numerical values to place those different things on the screen. So I'm going to close this, and I'm going to go back now to VS Code where we can start this process here. And so we're going to start with the thing that we always start with. We'll say import, let me zoom in a little bit here, pgz run. And then there's one other line that we're going to need to add to import in my code. So that's from platformer import star. And so that's going to import everything that is inside of this platformer here, which this is the stuff to build the platforms and read it in from that CSV file. And then there's a bunch of other stuff that I added here to support sprites, which we'll get to in a second. All right. So now what we're going to need to do is define some things for our platformer. So I'm going to call this like our platformer constants. And so these are special values that we're going to set that we're going to refer to kind of later on. And so this is first going to be our tile size. And we use all caps because they are constants, just indicating, hey, we shouldn't change these, kind of like width and height typically. But we want to be able to refer to them throughout the program. So our tile size here was just 18 by 18. So I'm going to put 18 here. And then the number of rows that we built into our level was 30. Basically, it was 30 by 20. So I'm going to say rows, and columns is going to be 20. And then what we're going to do is we're going to define the Pygame constants. And so those are the width, the height, and the title. So if I say width, what we're going to do is instead of just trying to calculate the value in our heads and determine what the width and height of the screen is based on the number of pixels in a tile and how many tiles we have, we can force Python to do the math for us. So I'm just going to say tile size times rows to make it multiply 18 times 30 because I'm lazy and I don't want it to do it. And it also helps us that if we ever change the map size, we can just change these values and it will propagate down. And then for this, I'll say tile size times columns. And then for title, this is just the name of it. So I'm just going to call it like platformer example. And this is what shows up kind of on the top of the window there. All right. And then we'll kind of finish out the basics here. So we'll do like our draw. And for right now, we'll just keep it empty and say pass. And then we'll do our update. And again, we'll just keep it empty and say pass. And then the very last line here, remember, is always going to be the pgz run.go. So if I run this here, we see this big window here. It's the correct size. It's this platform example, but nothing's being drawn on it, so it's just black. But that's what we need right now. All right, so I'm going to make this stop hiding my code so that you can see it. So I'm going to go to View and Appearance, and let's see, Panel Position. And instead of bottom, I'm going to select right, and that moves it over here so that you can better see all the code going on. Okay, so now we can see all this different information here from the CSV files, the comma separated value. So Excel makes it show up in that nice table, but here we can actually just see that it's a bunch of different numerical values corresponding to the different tiles with commas between them. So what we want to do is bring this into our game and show that information. And so the way to do that is using the build function that I built out for you. And so I'm going to show you how to do that. So I'm going to kind of put some code here under this part that says build world, and we're going to need to individually build each of the different parts. So I'm going to create a variable called platforms, and this is going to represent everything that's inside of the platformer underscore platforms.csv file. And so what I'll say is I'll say build, and we'll say platformer. We're going to say the name of the file here, which is platformer underscore platforms.csv. And then I'm going to put comma in 18 for the tile size. And actually, I should just use the variable we created right here called tile size. So there is our platforms. And to draw this, what this does is it creates each one of the different actors to represent each of the different tiles. And then this right here represents a list It tells us right there it's a list of platforms. And so if I want to draw each of the items in a list, all I'm going to do is I'm going to do it here inside of a loop. So the first part should always be screen.clear. And then what we can do is we can draw each one of the individual platforms. So let's also set like a nice background color for our game. So we're going to say screen fill. I think sky blue is a color. And then we can draw our platform. So we'll say draw all platforms. Platforms. So it's going to be for platform in platforms. Platform.draw. All right, so now we should see it clear the screen, draw the background sky blue, and then add each of the platforms in there. So hopefully this works. Let's see what we get. There we go. So it drew all of our different platforms, and now what we need to do is just do the same step for the obstacles and for the mushrooms. So I'm just going to copy and paste this line here, and instead of platforms, I will change this to say obstacles, and then this will also be obstacles. And then we'll do that once more for mushrooms. And then we'll do this for mushrooms. Great. And now we're going to draw each one of those different parts. So we'll say draw obstacles. And I can copy and paste this and then just change the variable names. Oh, that pasted weird. Indent. So this should say obstacles. And then I'm going to change this to say obstacle and obstacle. Because remember, this is just a variable that we are creating each time we go through the loop where it's going to grab one of the obstacles from the obstacles list and then draw them. And then we'll do the same thing now, but for mushrooms. So draw mushrooms, and then for mushroom in mushrooms, mushroom dot draw. And so now, when I run it, we should hopefully see everything. Yep. So we have everything here. And now we have each of these different types of things that were built into our different layers in different lists. So I can do different things if I detect a collision with an obstacle or if I detect a collision with the mushroom here. All right. So we've done all that. We've laid out our world. And now let's try to bring in an actor or a actor player to interact with this world here. And so what we're going to do is, let's see, if we go to GitHub here, I have some different things inside of images. So if you've downloaded this, you should have all these files. Let's use, here we go. We have P left, P right, P walk left, and P walk right. So this is just the different, should show it, there it is. So this little guy where he's facing in each direction and walking and stuff. So I'm just going to hit download to individually download each of these. And now they should be in my downloads folder. Let's see. So I'm going to move all of these now to, where is it? There it is. All right, so I'm going to move it now to our images. And then we have all of them here so that we can use it. So if I pull this back up here, we'll see images, and here it is. So let's create our little player here, and then we can draw them on the screen. All right, so where is it here? So we'll start by having them face to the right and kind of start them like towards the bottom-ish. So what I'm going to do is say define player actor, and we'll say player equals actor p underscore right. And then we'll just start them at the bottom of the screen. So I'm going to use the bottom left part of it. I'm going to set it equal to 0 for the x coordinate, so all the way to the left. And then I'll say, let's see, height minus the tile size. Because height's the bottom of the screen, but we put a tile down at the bottom. So height minus tile size should be standing right on that first little platform in the bottom left corner there. Let's see. I think that's all that we really need for right now. And what we'll do is we'll just say, let's draw the player, and we'll add them to the screen just to make sure that we did that correct. All right, so there they are. They're standing on the first platform. So that looks good. Okay. So now we need to add movement, which is something we've done before. And there's other examples kind of in the GitHub repository showing you how to do the left and right movement and the jump to incorporate gravity. So I'm going to kind of go through this a little bit quick because we've gone through it before. But you can follow along with me if you want here. All right, so this is all going to go inside of update because this is where we're going to handle the game state. We're handling where the player is moving throughout before we draw the screen again. And so let's see. We're going to add our different conditional statements for handling left movement and then handling right movement. And then we'll do the gravity stuff. So we'll say handle gravity. This is kind of going to be the 3 different chunks here for this. So we'll start by saying if keyboard dot left. So if the keyboard left button is held down, what we'll do is we'll move the player to the left, and then we can show the left facing image and vice versa. And so what we're going to do is we're going to go back up here and we're going to introduce a couple of player actor specific variables. So I'll say define actor specific variables. And this is where we create variables that are specifically tied to player. And we do that by saying like player dot. And so what I'm going to do is I'm going to create velocity x to kind of represent how the change in position for each frame. So how far the player would move x to the right or to the left each time the frame updates here. And so we're going to set this to be 3. And then we'll also do a y velocity component. So I'll say player dot velocity underscore y, and we'll set that equal to 0 here. And this is something we'll change whenever they jump. All right, so if we come back down here, we'll say if keyboard dot left, then what we'll do is make it show the left facing image and change the x position there. So let's go through that process. We would say player dot x, and if they're moving to the left, they're moving in the negative direction. So we'll say minus equal player dot velocity underscore x, and then we'll say show the player dot image p left, which is them facing the other direction. Right? Yes. Okay. And then what we'll do is we're going to do the same thing but for right. So I'll copy and paste this down here, and we can make this an elif, and then we'll say keyboard dot right, and then instead of subtracting we will add, and instead of setting to this we'll do that. So let's run this and see what we get. We should get some left and right movement here. And yeah, we're not really interacting with the world at all, but I can move left and right when I hold down the left and right arrow keys. So we're in fairly decent shape there. But it does let us go off the screen, so we need to incorporate that other part into our conditional statements to make sure that we don't allow it to move any farther than the screen. And so what we need to do is we need to check the leftmost position, in this case, of the actor. And so that's by checking mid-left 0, which is going to give us the x-coordinate of the leftmost position of the player. And we'll say, if it's greater than 0, then we'll allow it to continue to subtract. Otherwise, we don't want to do that. And then we'll do the same thing here, but instead what we'll do is we'll say and player dot mid right. And instead of seeing if it's greater than 0, what we want to do is see that it's less than the width of the screen, meaning that it hasn't gone off to the right. Okay? So now if we run this again, you should see that we have the same left and right, but it stops me when I get to the edge of the screen. All right, so let's add some gravity stuff here. All right, so this is something that we've done a little bit before. We did it in our cactus runner game and stuff like that. And so the first step is going to be to add a on key down event listener here. And so what we'll do is we'll detect whenever the up key is pressed, and we will change the y velocity so that it goes up and then eventually back down. So what we'll do is we'll say if key equals keys dot up, then what we want to do is make player dot velocity y equal, we'll say equal, let's define a variable up here. Let's define a couple of global variables up at the top. So I'm going to add another section here that says define global variables. And for jumping, what we need is gravity, some variable to represent gravity, and I'm just going to set that equal to 1. And then we're going to have another one called jump velocity. And that's going to represent what we're going to set the y velocity component to be equal to whenever that is pressed. So I'm going to start it at -10, and we'll see how that works, and we'll go from there. And so if we go back down to our on key down here, what we'll do is we'll just set player.velocity underscore y to be equal to jump velocity. So that way we can just change it up top, and we can refer to this variable kind of throughout. It might be helpful in a couple other places here. So in order to handle gravity, there's a few things we have to do. So first, we're going to change the y position of the player by saying player.y plus equal player.velocity underscore y to change it by that velocity part each time. So it starts at -10, so it will add -10 to it, making it go up 10 pixels. And then what we're going to do is we're going to change the velocity by adding gravity to it, which has a value of 1. And so what that's going to do is it's going to make our player start to decelerate as it's going up and then accelerate as it's going down. Because if we think about it, player.velocity y starts at -10, and so if we add gravity to it, it goes to -9, then -8, then -7, 6, 5, 4, 3, 2, 1. So it's changing in the upwards direction by less and less each time until it reaches 0, and then we're still adding gravity to it. We're adding gravity which equals 1, so then it starts to go positive, and then it goes from 0 to 1 to 2 to 3 to 4, and so it then starts to increase the amount by which it is dropping down. And so that's how we're going to handle gravity here in our game. All right. And then what we're going to do is do a couple of different things, right? So let's see. If I run it right now and I jump, let's see what happens. Well, the player was there, but gravity was involved, so the player just kind of fell all the way through the floor. So let's see if we run it and take a look real quick if we can see it. Yeah, so it started there and it fell through the floor. So now we're getting to the part where we have to actually detect collision with the different things here so that gravity doesn't factor in once we're standing on a platform. And so we're going to do a little bit of stuff here, all right? So what we'll do is if the player collided with a platform, we're going to add that here, all right? So what we're going to do is we're going to use a new type of collision thing called collide list. And so what this will do is tell us if one actor has collided with a list of different actors here. And so the list of actors that we care about right now is going to be platforms. And so if the player collided with a platform, what it will do is it will tell us the index of which platform the player collided with. So say I have 5 different platforms. If I collided with the first platform, it would give me a value 0 to indicate that I collided with the platform at index 0. If I don't collide with any of the platforms, what it will do is give me -1, indicating that there was no platform collision detected. So what I'll say is if player.collide list with platforms does not equal -1. And so remember, it will give me -1 if I don't collide. So I'm saying if it does not equal -1, meaning that there was some collision, then what we want to do is go inside of here and handle that collision. And so what I'm going to do is I'm first going to say get object that the player collided with. And so we're going to do the same thing right here, but I'm going to store it inside of a variable. So I'm going to say object equals platforms and then player dot collide list platforms. Because what this does is it gets me the index of which one the player collided with, and then by using platforms with a square bracket, what it's going to do is it's going to index that list and just return back the single platform that the player collided with. And it's going to be important to get that one very specific platform because we want to know the location of that platform here for a couple of different reasons. Okay? So, what we're going to do is, we'll say if they collided with that, we can just set the velocity. Let's start like that. Yeah, let's just set the velocity to be 0. And we'll come back to using this here in a second. So we'll say velocity y equals 0. And then we will set the position kind of in relation to this object here. All right. So if they collided with this object, we could say, let's set the y position of the player to be something in relation to that object there, right? So what's happening is we're changing the y position right here. And so if that change in the y position causes a collision, what we want to do is get the object it collided with and then set the y of the player to be now on top of the object it collided with. And so if I set it just to be object.y, remember player.y is going to set the center position of the player, and object.y is going to get me the center of the object. So that would just place the actor right over top of the block. So we don't want that. We want it standing on top of the block here. So if I ran this, I think we'd get some kind of weird behavior. Yeah, so it places them right there on top of it. And I can't jump because I'm immediately colliding with it because I'm sitting on it. So what we need to do is change this line right here, 66, to place it on top of this, right? So what I need to do here is I need to take the position of the object itself and then subtract something to set it on top. Because remember, if I subtract a value, I'm moving up in the y direction here. And so what we need to do is we need to take into account the height of the player and the height of the object here. And so in order to do that, what we'll do is we'll say, let's subtract object.height divided by 2 plus player.height divided by 2. And what that means is like, let's take the height of the object, so the height of the platform there, and divide it by 2 because we're talking about the midpoint of the object when we say object.that. So if I subtract the half of the height, that's going to move me to the very top of the object. And then if I subtract half of the player height, what it will do is it will set that y position to be just above there. So this should be what we want. So let me run this and see. Yeah, so now we're sitting on it, and I can jump and land on it. Oh, and we had a little bit of weird behavior there where I start to zoom up through things. But we'll talk about how to deal with that, because yeah, look, it's making it easy for me. Whenever I collide with any object, I go up on top of it. And that's because we've only handled collisions when we're adding the y velocity here. So, you know, that would make our game very easy, but we want it to kind of behave more like we would expect, right? And eventually we'll add the spikes in here. All right, so what we need to do is also handle collisions with the X and the Y position, like the left and the right are on the X axis. So if I run into a platform this way, we don't want it to go right on top. We basically want it to stay to the left of it, right? So if I'm moving this way and I hit it, I don't want to suddenly appear on top, which is what's happening right now. I want to appear just to the left of it, so I can't go through this. And same for if we're moving this way from the right side. If I hit it, what I want to do is stand off to the right of it, not just suddenly appear on top of it, which is what's happening right now. So we're going to do a very similar thing that we did here, but we're going to add that functionality up top here. All right. So what is this going to look like? Well, the first part's going to look like this right here, right? So I'm going to copy and paste this and place it inside of the left, and then I need to do some indenting to make it work properly. So what this is saying is that if this change in the X position somehow caused a collision, let's get that object again, the object that we collided with. And then what we'll need to do is do a kind of a similar weird calculation down here that we did for Y, but do it for our X. Because we're only going to handle one direction at a time, either our X direction or our Y direction, because we are only changing the X value right here. So if that change in the X caused a collision, we want to handle that. And then down here, if that change in that Y position caused a collision, we'll handle that. We want to handle each part separately or else it gets too complicated. And so what we're going to do is we're going to set the new player.x position once we've detected that there was a collision caused by that movement in the X direction. And what we'll do is we'll say, okay, we want to set that position again in relation to the object. So object.x, just like we did object.y here. But now what we need to do is take into consideration the width as opposed to the height here. And so since we're talking about a movement to the left, right? So this might behave weird, but what I'm saying is we're moving to the left. So if we hit this, we need to shift back in the positive X direction, meaning to the right. And so what I'm going to do is we're now going to add a similar thing right here. So I'm going to copy this here, but instead of saying half the object height and half the player height, we're going to change this to be the object width and the player width. Right? And so that should handle all of it for moving to the left. And now for moving to the right, we're going to do a very similar thing, but we just need to change this to be minus. That's the only difference here. So when we're moving, do I still have it up? No. When we're moving towards the right, if we hit something, we want to subtract the width of the object and the width of the player to set it back off to the left of it. So now if I run this, we see that I can actually fall through that, which is a good sign. But I can no longer do like that thing where I was running up all of them, but I do still zoom through the platforms. Oh, I fell through. Let me restart it. I do zoom through the platforms when I hit them from below, which would be nice if we were trying to make like one-way platforms, where meaning you can jump up through them, but you can't go down through them. But what we're going to do is try to make these solid so that you can't go up or down through them. You have to jump over them like this. All right. So that means we need to add a little bit more logic here to detect if we are going up and like the player hits their head, or if we're coming down in our trajectory here and we want them to land on the platform. And so that's going to require a few more steps here. All right. So the first thing is we're going to need to know if the player is moving up or moving down. All right. So what that's going to entail is, let's see, we'll go here, and first we'll just get that object, and then we're going to incorporate this part of the code in there elsewhere based on whether it's moving up or down, where we would either add or subtract, just like we did with the left and right position. So here what I'm going to do is I'm going to say if player dot velocity underscore y. So if the y velocity is greater than 0, what that means is they are moving downward. So moving down, which means that they hit the ground, right? And then I could add an else here and say else. That would mean that they are moving up, which means that they hit their head, right? Because if the velocity is greater than or equal to 0, what that means is we're adding to the y position, moving it down the screen. And so that means that they are moving down, right? So we need to handle each of these separately, kind of like we handled it separately here. All right, so if they are moving up and bump their head, we want basically the opposite of this one here. So what I'm going to do is I'm going to say, let's copy this right here. And then I'm going to copy this and paste it right here and nest it inside of there, but change this to be positive, right? So if they hit their head, we want to add the object height and the player height so that it moves it below the block. Whereas if they're moving down and they hit it, we want to subtract the object height and the player height to set it on top of the block. And then if either of those things happen, right, if we collided with a platform, what we're going to do is we're just going to set the player velocity equal to 0 so that they stop moving kind of up or down, right? And they stop going in that different direction. So let's see if this handles it properly. We might be missing something. Let's give it a go. All right. So now I'm hitting my head and I'm not zooming through that, so that looks good. And yeah, I think this is looking good. We're able to run and jump and get to everywhere. But the one thing that we didn't handle is I can hit the up arrow key a bunch and I can just keep jumping kind of infinitely. And so if we only want the player to be able to jump once, we need to introduce another player or actor specific variable for the player to prevent them from jumping that many times. All right, so we'll say like if they're already jumping, don't let them jump again. All right, so what we're gonna have to do is we're gonna go up to here and we're gonna create a new actor specific variable and we'll say player.jumping. And it's going to be a Boolean value, either true or false, based on whether or not the player is jumping. And so we're going to start it off at false. And down here, when we detect this, we'll say, okay, let's change it to be player.jumping equals true. And because this is an actor specific variable, I don't have to declare it as global, which is kind of the nice thing about it. We can just say player.jumping equals true, and I don't have to say global jumping up top here. All right, so we'll set it equal to true. The other thing we want to do is say if the player's already jumping, we don't want them to be able to jump again. So we're going to change this conditional statement here to say and not player.jumping, meaning that if the arrow key was pressed and the player wasn't already jumping, then do this. But if the arrow key is not pressed or the player was jumping, we're not going to increase the velocity. So that should handle that, but there's one last thing we have to add, but let's check this out. So when I hit it, I can't double jump, but then it never lets me jump again because player.jumping is always equal to true. So I need to think about where I want to set that back to be false. And so what we'll do is we'll set it back to false whenever they land on the ground. So if we go back here, whenever they hit the ground, that would be this case right here. So just inside of here, I'll say, let's set player.jumping equal to false. And then it should allow us to jump again whenever we hit that. And so now we have most of our physics down for moving our player around and having them land on the platforms. But we just need to handle our cases now for the mushrooms and for the obstacles. All right, so this is what we've got so far. So what we're going to do is after we handle all the movement here, we're going to add some stuff. So let's first do the, let's see, check collision with obstacles. And so what we're going to do is if the player collided with the obstacles, we're just going to kind of do like some game over condition here. All right. And so what we'll do is, since we know about collide lists, which will check collision with any actor in a list of different actors, what we'll do is say if player.collide list with an obstacle, right? So if they collided with an obstacle, that means that this function right here would return something that is not -1. It would return the index of whatever it collided with. So what we'll say is if it doesn't equal -1, that means that they did collide with something. And then we will just set the game state to be over. And let's do a couple of things here. So what we'll do is we're going to create an actor specific variable here that says player.alive. And we're going to start this as being true. And then if the player lands on a spike, we'll set it to be false. So I'm going to come down here and say player.alive equals false. And then we can, based on the value of this Boolean variable here, if it's either true or false, we will draw the player. So I will say if player.alive, meaning if player alive equals true and the player is alive, then we'll draw it. All right, so let's see if this works. So if I'm running, yeah, when I hit a spike, the player disappears. I mean, earlier, the player just kind of continued to fall through the floor, right, and essentially disappeared. But if I ever had an obstacle like somewhere else where they wouldn't fall through the floor due to gravity, they would also disappear. So that works kind of the way that we want it to. Let's do another global variable here that is just over, and we'll say a couple things here. So we're going to say over equals false, meaning that the game is not over. And then inside of here, I'll say global over, because it's a global variable that is a Boolean value, so we need to declare it as global. Then down inside of here, I can say over equals true. And then what we can do is we can just kind of display some game over message. So up here, we'll say display messages. So we'll say if over, meaning that the game is over. We'll say screen.draw.text. We'll just say game over. And then we'll set the message to be in the center of the screen by saying width divided by 2 and height divided by 2, like that. And now if I land on something, yep, we get our game over message. All right, so the last step here, I think, is going to be to handle the collision with the mushrooms here. So what we'll do is we're going to kind of do this in the same way that we did our coins, right? So we're going to check mushroom collision. So we're not going to use collide list. We're going to loop through each one so that we can remove it once we've found it. So I'm going to say for mushroom in mushrooms, if player dot collide rect with mushroom, then mushrooms dot remove mushroom. Right, so if they collided with that specific mushroom, what we want to do is remove that from the list here. And that should count as collecting them. So let's run this back and see if I pick them up. Yeah. So there we go. I'm picking up each one of the different ones. Oh, and then I lost. All right, so let's do another thing where we're going to, if they collect all of them, we will say that they won. And so what we're going to do is, let's do a couple things here. Let's say win equals false, a global variable called win that will set to true whenever they win. And we'll add another message here. So we'll say if win, I'm going to copy this and paste it. But instead of game over, we'll just say you win, like this. And then we just need to figure out where we're going to set when to be true. So it's a global variable. We're going to set it inside of update. So I'm going to say global over and global when. And then down here, if they've collected all the mushrooms, then we'll say that they won. And so what that means is that if the length of mushrooms, basically our list of all the mushroom actors, if that equals 0, then they've won. All right, and so we can run this, and let's see how long it. Oh, didn't take me very long to lose. I think I'm gonna hit my head regardless there. So I'm gonna go over this first one and say boom, 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 boom. Should have made this easier for myself. This might take a while. Or you could just take my word that if we collect them all, then it should win. Oh, let's see. This could be it. I could do it. There we go. All right, and I won. So perfect. The game seems like it's working well. And so that's the basics for getting a platformer down. So that's using tiled, using the tile maps, getting the physics down. And so what I'm going to do now is show you how to adapt this to use sprites if you do want to use sprites in your game. And that is some additional functionality that I added here inside of this platformer.py. So I'll show you how to adapt your code. Instead of using this one little image of a guy, we're going to use an animated sprite here. And so let's start by adding the sprite asset. And so I found this one on itch.io. It's just called 2D pixel art fox sprites. And we're going to use this one because I think it's a good example, and I'll show you the image here in a second to show you how it's laid out and why I think it's a good example, because it's pretty common to how a lot of them are shown, right? And so this is something known as a sprite sheet, where it's individual frames of a different animation for the character. And so it goes across horizontally. So this is one sprite here, and this is just kind of like an idle sprite, like the fox is kind of standing there, and its tail is wagging around. And so then this is another one, I guess another kind of idle sprite, right, where it's a little bit longer. They're looking around and their tail is flapping. This one here, they're running along. This one is a jump, sleeping. There's all these different things here. So what we're going to do is, instead of setting a specific image, we're going to set a specific sprite and kind of change the rate that it goes through the different images here. So I will show you how to do that. But the first step is we need to bring this into our environment. So I am going to move this here into images, but I need to create a new folder here called sprites, because we're going to treat these a little bit different. So we're going to put it in a separate folder here called sprites, and I'm going to move this here. And the other thing we need to remember to do is to follow the naming conventions for Pygame Zero. We need to rename this to be all lowercase, no spaces. So I'm just going to call it Fox. All right, and then we go back to our VS Code environment. We should see that we have sprites and we have Fox right there. All right. So what we're going to need to do is first define the sprites, and then we can define a special type of actor that we're going to call a sprite actor. So I'm going to put it right here before we define our currently existing actor. All right, so we're going to say define sprites. All right, and so the sprites expect a few different things, and if you go inside of here, you could kind of see some of that, but I'll walk you through this process here. So this is basically what it expects. I'm going to kind of paste this information right here, where we're going to declare some new sprite. We're going to give it the name of the sprite. We're going to tell it the start position of the top left coordinate of the sprite. We're going to tell it the number of frames that's going, the number of frames in it. We're going to tell it the color key, and then we're going to tell it how fast we want it to refresh, or like how many frames, because we're drawing at 60 frames per second, so we'll tell it how many frames we want it to refresh. So if I said 30, it would refresh like every 30 frames or something like that. So that's what we're going for here. So what we're going to do is we're going to do, I guess, two different ones. We'll have fox stand, and we will have fox walk. And so we're going to follow the same format here, where we're going to copy this. We're going to say fox stand equals that, and fox walk equals that. All right. And so for our image, it's just going to be fox.png. And for this one, we do need to have the file extension here. For our actors, right, we didn't say like p_right.png, but we do need this .png here. And then what we'll do is we'll say, okay, this is a value similar to how we treated rectangles when we were drawing them, where there was some x and y coordinate, and then there was some width and some height, okay? So this x and y coordinate is the starting top left position of our sprite. So if I pull this guy up again and we'll zoom in, that would be like, if I'm trying to use this one, the top left would be this point right here. So 0, 0. And then we would say the width and height, which for this one is going to be 32 by 32. You could see that kind of if you pulled it up here. All right. So if I wanted to show this first kind of row of sprites here, it would be 0, 0, 32, 32. I would write it like this here. 0, 0, and 32, 32. But actually, I want to show this longer one as the stand or the idle one. So what we're going to do is we're going to choose the top left corner of this. And so instead of being 0, 0, it's going to be 0 for our x coordinate, but 32 for our y coordinate here. And then the width and height are still going to be 32 by 32. Okay. And then what we need to do is we need to count the number of frames in it. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 frames. So I'm going to put that here. And then this color key is just going to be kind of an odd value that should set the transparency color for the background. Basically, what I would do is just use this right here, this tuple 0, 0, 0. For your color key. Unless something misbehaves, then come chat with me and I'll try and help you figure it out. But yeah, just kind of use this default value here. So I'm setting a variable equal to that, so we can just use that in both of these places here. But then the last thing, what we're going to do is we're going to set the refresh rate, or how many frames between each time we want to cycle to a next part of the sprite. And so for this one, I'm going to start at 30. For the stand, because they're standing, we want it to go a little bit slower. We'll do a little bit of a faster one for the walk. But our walk, let's see, what is that going to be? We're going to do this one right here, okay? So that's going to be, we'll change this to say fox. And then the start position for that is going to be, again, 0 for the x. But for the y, it's going to be here at 64. So we could say 64, 32, 32, because the width and height are going to be the same. The number of frames is going to be 1, 2, 3, 4, 5, 6, 7, 8. And then we'll use color key, again, that variable right here that we created, and we'll set the refresh rate to be 5. All right, perfect. So now what we need to do is create our actor as a sprite actor and then set the various sprites here. And so what we're going to do is this. Instead of creating a actor, we're going to create a sprite actor. And then what it wants as an argument inside of here, or the value that we're going to pass inside of here, is one of these sprites that we want it to start out as. So I'm going to set it equal to fox stand. All right. Now, fox stand is going to be shown at the beginning. And now what we need to do is everywhere we were changing the image, we're going to have to remove that and think about when we're going to want to change the sprite. Okay. So if they're moving left or if they're moving right, what we'll want to do is show that sprite. So I'm going to we'll just get rid of this line and we'll say, okay, change it to player.sprite to adjust the sprite. And what we'll do is we'll set the sprite now equal to fox_walk, right? And we'll do the same thing down here. We'll make them walk whenever we hit the left or the right key. All right, so that makes sense to me. And then let's see. So what we want it to do is then change back to the stand whenever we stop moving to the left or the right. And so what we'll do is we'll create a new event listener down here for on key up, meaning that whenever a key is released, this will be called. And so what we want to do is specifically say if the key that is released is keys dot left, or the key is keys dot right, then what we'll do is we'll set the fox.sprite equal to fox_stand. So if we hit left, it'll change it to fox walk. If we hit right, it'll change it to fox walk. If we release it, it'll do this, okay? So I'm gonna save it and we'll run it and hopefully we don't have any errors. All right, there's our fox and it's animated. It's kind of moving through the different things. Uh-oh. Oh, I said fox. This should say player. All right, there we go. That's why it crashed. But it did look like it was working there for a second. All right, so now it's doing that. And when I run, it goes through the run animation there. It's a little small, so it's kind of hard to see. Right? But the thing that's odd now is we don't have a left and right facing version of the sprite, right? So if I move to the left, it just kind of looks like it's moonwalking backwards. So what we want to do is flip the direction that the sprite is facing. And that's another thing that I've added into the code here for the sprite actor is we can flip it so that it's kind of mirrored across the vertical axis here. And so in order to do that, what we're going to do is we're going to say flip x. So here what we'll do is we'll say if it's moving to the left, because by default our image is facing to the right, what we want to do is flip it so that it's facing the other way. So here what I'll say is I'll say player dot flip underscore x, and we're going to set that equal to true, meaning that we do want it to flip about on the x right there, okay? And then when we're pressing it to the right, what we're going to want to do is set that value equal to false so that it is no longer flipped. And that should handle it for us here. So if I go here, I'm pressing it to the right, and now I'm pressing the left. And our guy kind of flips back and forth here, which is perfect. So there we go. Perfect. All right, so that's how you work with sprites here. There is some other functionality that I've added as well. So if you get a sprite or an image that is too small or too large, there is a scaling factor that you can now set. So if I hit scale ×2, what it will do is it will make the actor double the size, right? And so now I'm too large, and I'm hitting my head, and I can't really move in that direction. But yeah, that's how this works here, right? And if it's too small, what I can do is, okay, I'll set it to 0.5, and then it will draw it as like even smaller down there, okay? So that's how you can help adjust the size there of that. But for this one, using a player scale of 1 or just leaving it as is works for the game. All right, so I know that was a lot that I threw at you, but hopefully you can skip through to see the different parts that are pertinent to you. And all of this information is posted on Canvas and in the GitHub repository. The examples are here. So if you go to CS4040, this one is the basic physics of the platformer. This one is showing the basics of the sprite actor. And then this one is kind of basically what we just went through, combining both of these to do the platformer physics with the sprite actor to show that. But yeah, hopefully this is helpful. Don't hesitate to reach out if you got any questions.